All right, we have another inverse Laplace transform to find. This is also not directly on the table, and we have to make it fit the table. And the way we're going to make this fit the table is we're going to break it up as a partial fraction decomposition. And this will be very common in our problems this semester, that we have to do this kind of partial fraction decomposition. So this is the right form for the decomposition. This is a irreducible quadratic factor in the denominator, so that requires a bs plus c in the numerator here. Let's multiply through by the common denominator. So I have s equals a times s squared plus 3 plus bs plus c times s minus 1. So s equals as squared plus 3a plus bs squared plus cs minus bs minus c. And finally, grouping the like powers, that looks like a plus b times s squared plus c minus b times s plus 3a minus c. And that all has to equal s. So now that the powers are grouped, we can create a system of equations and unknowns based on matching coefficients. There's no s squared on the left and a plus bs squared on the right. So I have a plus b is 0. There's an s, one s on the left, and c minus b s on the right, so that coefficient has to equal 1. There's no constant term on the left, so our constant term, 3a minus c, is going to be a 0. So we have this system of 3 equations and 3 unknowns. From the first equation, I can see that a must equal negative b. I can plug that into the second equation here, and that looks like a plus c equals 1. I've replaced b with negative a. And then I have 3a minus c equals 0. So if I add these two equations together, I get 4a equals 1. So a is 1/4. That means, well, let's write it all out here. A is 1/4. That means b is a negative 1/4 because a plus b has to equal 0, or a is just the negative of b. And then a plus c is 1. A is 1/4, so c must be 3/4. So that's our partial fraction decomposition. Let's go back, erase this, and go back and see how we use this to get our inverse transform. All right, this is what we discovered through our partial fraction decomposition. We had a was 1/4. B was a negative 1/4, and C was 3/4. So we've split this fraction up into two fractions over the same common denominator. These are now pieces that look a lot like lines in our table. This one looks like line number 12. This one looks like line number 13. And this one is line number 14 in our Laplace transform table. They are all ready to go except here in line 14, it's s squared plus k squared, and it's k over s squared plus k squared in that line. What that means is we have the 3 in the denominator. We need a square root of 3 in the numerator. So we do the square root of 3 over square root of 3 multiply divide trick. And now it's in the right form for us to do the inverse. And now we can just write out what the inverse is. The inverse is 1/4 e to the t minus 1/4. This is a cosine of the square root of 3 times t, right? In the table, it was s over s squared plus k squared goes to the cosine of kt. So we have a 3 here, which is the k squared. So k is the square root of 3. So the cosine is the square root of 3t. And then I have plus 3 over 4, or square root of 3 times 4 times the sine of the square root of 3t. I could simplify this fraction a little bit, but I don't need to. This is the inverse Laplace transform.